Hello everyone, I'm Yazan Ibrahim, or as some of you might know me, Yazan Abu Ghosh. Today we're going to dive into a fascinating and essential topic from Chapter 5, Protection of Information Assets. Part A, Information Asset Security and Control 5.5, Network and Endpoint Security. If you are a seasoned auditor or just curious to understand how information systems into business environments, you've come to the right place. Let's begin. When we think about security in our interconnected world, the importance of network and endpoint security cannot be overstated. Every enterprise today, regardless of its size or industry, relies on secure networks to protect sensitive data, ensure business continuity, and ward off growing cyber threats. This isn't just about blocking attacks at the front door. It's about creating a multi-layered shield that extends throughout an organization's digital infrastructure. So, how do modern enterprises effectively safeguard their networks? The answer begins with perimeter security controls. Think of these as the outer walls of a fortress. Tools such as firewalls and intrusion detection systems, IDSs, monitor and control access across the borders where trusted internal networks meet untrusted external ones like the internet. But here's the catch. Even these systems are only as good as their implementation and maintenance. A firewall, no matter how advanced, becomes a liability if left misconfigured or outdated. Similarly, an IDS without proper monitoring is like an alarm system no one is listening to. This brings us to the underlying architecture, the blueprint of all modern networks. To truly grasp network security, we need to dive deeper into the nuts and bolts of how networks operate, connect, and communicate. And the evolution of networks were born out of necessity, a need to share information, collaborate, and improve productivity. Picture an office decades ago where computers sat in isolation, disconnected from one another. The ability to link these systems revolutionized how work was done. Over time, networks evolved, supporting telecommunication links with both dedicated circuits, permanent connections between 2 points, and switched circuits, flexible connections established on demand. Dedicated circuits work much like a leased private road. They're always open, reserved exclusively for 2 locations to communicate. Switched circuits, on the other hand, are like public highways. They connect endpoints only when needed, often relying on mechanisms like circuit switching or packet switching. While circuit switching sets up a direct connection, commonly seen in telephone networks, packet switching breaks data into smaller chunks or packets that travel independently through a shared network. The efficiency of this method has made it a cornerstone of modern networking technologies, like the internet. Packet switching also paved the way for virtual circuits, where packets from different sources share carrier networks, creating a system that appears seamless to the user. Technologies like asynchronous transfer mode, ATM, and frame relay utilize these concepts, enabling organizations to transmit data at lower costs. Inside modern enterprise networks, today's enterprise networks resemble sprawling cities, intricately segmented for efficiency and security. These networks often adopt specialized architectures to serve distinct purposes. At one end, you might find clusters of application servers, systems that deliver web pages or run business-critical applications. At another, there could be storage area networks, SANs, dedicated to handling vast volumes of data. Meanwhile, employees connect via local area networks, LANs, tailored to their specific needs. Some organizations have embraced service-oriented architectures, SOA, which operate like modular city grids. Here, different systems communicate using web-based technologies like Simple Object Access Protocol, SOAP, or Extensible Markup Language, XML, enabling information to flow freely across departments or even continents. However, as these networks grow in complexity, they demand careful planning. To truly design and secure such networks, professionals must dive into technical details, like the specifications of communication technologies, types of network topologies, and the protocols that ensure seamless communication. Types of networks are not one size fits all. Each type serves a different purpose and comes with its own unique characteristics. Personal area networks, PANs, connect devices within a few feet of an individual, such as a smartphone and a smartwatch. They rely on technologies like Bluetooth for short-range communication. Local area networks, LANs, typically cover a building or office. These are the workhorses of connectivity, powered by Ethernet or Wi-Fi for high-speed data transfer. Wide area networks, WANs, extend across cities or even countries, connecting multiple LANs. The internet itself is a WAN, albeit a massive and public one, while many businesses maintain private WANs for secure inter-office communication. Storage area networks, SANs, centralize data storage, ensuring servers can access critical files quickly and efficiently. Each of these designs meets specific business needs, but together they form the backbone of today's digital environments. The OSI model, making sense of communication layers. At the heart of network design lies the Open Systems Interconnection Model, or OSI model. Developed to standardize digital communication, the OSI framework organizes networking into 7 distinct layers, each with its own role. 1. Physical layer, where data becomes electrical, optical, or radio signals, traveling through cables, fiber optics, or the air itself. 2. Data link layer, responsible for transferring data across a single network link, ensuring it arrives intact. 3. Network layer, the decision maker for routing, using IP addresses to determine the shortest path to the destination. 4. Transport layer, ensures reliable delivery of data. It's like a courier confirming the package not only arrives but isn't damaged. 5. Session layer, manages the ongoing conversation between two devices. 6. Presentation layer, formats data for transport, including tasks like encryption and compression. 7. Application layer, provides services directly to the user, like email, file transfer, or web browsing. Even though you can't see these layers in action, they're working hard every time you send a file, make a Zoom call, or open a web page, converting and encoding data while ensuring it reaches the right device. Building a secure network. Let's circle back to security because no matter how advanced a network, its vulnerabilities can undo everything. Network services like file sharing, email systems, and remote access open doors to convenience, but also potential risks. Without proper safeguards, issues like unauthorized access, data interception, and viruses can wreak havoc. This is why enterprise-grade security measures go far beyond antivirus software. They use tools like Dynamic Host Configuration Protocol, DHCP, to manage IP address distribution, domain name system, DNS services, to translate domain names into IP addresses, and authentication protocols to verify every user attempting to connect. Additionally, switches have largely replaced hubs in modern LANs, improving both performance and security. Switches ensure that each device has a direct connection, reducing the chances of eavesdropping and network congestion beyond LANs, D1s, and VPNs. As networks grow, many organizations extend operations using wide area networks, WANs. WANs often employ technologies like fiber optics, satellites, or even microwave transmission to bridge geographic distances. But connecting through public infrastructure comes with its own set of challenges, primarily the risk of exposure. This is where virtual private networks, VPNs, come in. A VPN creates a secure tunnel over the internet, encrypting data as it travels between remote users and central offices, or between business partners collaborating across networks. It's secure, efficient, and cost-effective compared to leased lines, making it a popular choice for modern enterprises. Conclusion: the integrated pillars of network security. The world of network security is vast, and building a resilient system involves understanding its many layers, from choosing the right physical media, like fiber optics or twisted pairs, to implementing robust firewall policies. Furthermore, standards like the OSI model provide a structured framework, ensuring every communication, no matter how complex, flows seamlessly and securely. Every organization today is part of a larger interconnected ecosystem. The lines between offices blur as data traverses global cloud systems, VPNs, and wireless networks. Secure networks don't just fuel business, they ensure trust. Because in a digital world, trust is the foundation upon which every enterprise is built. Have you ever wondered about the complex systems working behind the scenes every time you send an email, browse a website, or access a remote server? Beneath the easy-to-use interfaces we interact with every day lies a meticulously structured network infrastructure. From data packets, hopping between devices, to sophisticated protocols ensuring our communication is safe and efficient, every step is part of this invisible web. Let's embark on a journey to uncover the building blocks that power this connectivity. We'll explore everything from the protocols enabling seamless file transfers to the mechanics of data security and even the intriguing structures behind client-server technology. Each concept shapes our interconnected world, and understanding them is like peeking into the blueprint of modern communication. The cornerstones of networking. At the foundation of any discussion about networks are protocols, rules that dictate how devices interact, share, and manage data. One of the most essential tools in this digital toolkit is the Domain Name System, or DNS. Imagine DNS as the phone book of the internet. When you enter a website's name, like www.example.com, The DNS translates it into the corresponding IP address, a precise locator, so your computer knows where to go. Without DNS, you'd be left memorizing the IP addresses of every website. Complementing DNS is the File Transfer Protocol, or FTP, which specializes in the movement of files across the internet. Think of it as a transporter carrying programs, images, documents, or music between devices. Whether you're downloading a file from a public server or uploading your work to a shared system, FTP makes it happen. But as convenient as FTP is, it also comes with risks. For instance, anonymous FTP, a practice where login credentials aren't required, can leave servers vulnerable to malicious uploads or unauthorized changes if administrators don't set proper permissions. It's a stark reminder of why security is critical in every layer of networking. Protocols that shape our communication. Speaking of the internet, let's discuss what happens when we connect. That connection between your device and your internet service provider, ISP, acts like a bridge linking you to the vast landscape of online information. ISPs, in turn, often route your data through traffic hubs known as network access points, or NAPs. Picture them as bustling intersections where massive highways of data converge and disperse. But how do you securely control remote systems? Enter Secure Shell, SSH, a network protocol that encrypts communication between computers, preventing unauthorized access. SSH is critical for tasks like remote command line access or executing commands across systems. However, when encryption isn't an option, outdated protocols like Telnet pose security risks. Unlike SSH, Telnet sends everything in plain text, leaving sensitive data exposed. Breaking borders with trans-border data flow. Let's take a step back and look at the bigger picture. Trans-border data flow. Today's global businesses are constantly transmitting data, emails, invoices, payment confirmations, back and forth across borders. This is often done via suboceanic cables, satellites, or even telephone links. But with this convenience comes a host of challenges. Different countries enforce different laws when it comes to data security, encryption, and privacy. For instance, some nations regulate which encryption methods can be used or enforce strict protections on personal information. Problems arise when these laws conflict, especially when your data takes an unexpected route thanks to the unpredictable nature of internet routing. A simple domestic email might accidentally hop through servers in another country, exposing it to conflicting regulations. For businesses, understanding these legal differences isn't just practical, it's essential. They need strategies to comply with laws while maintaining the confidentiality and security of their data. The pulse of network performance. Performance is a key aspect of networking, and two metrics dominate conversations: latency and throughput. Latency measures delay. Imagine sending a message to a friend and waiting for their reply. The pause is latency. On a network, latency occurs because data has to travel through multiple devices, switches, routers, physical distances, and might even get queued up if devices are busy. Measuring it is as simple as using the ping command on your computer. Throughput, on the other hand, is about speed, how much data can flow between 2 points in a given time. Think of it as the width of a highway. The more lanes, the more cars or data packets can pass. Together, latency and throughput dictate the user experience. Buffering during a video call? That's likely high latency or low throughput at work. The client-server revolution. Behind many internet services lies the ever-functional client-server architecture. It's an ingenious design where work is split in two. The client, your computer or device, and the server, a remote system providing data or services. The synergy between these components powers everything from file-sharing networks to web applications. You've likely encountered thin clients, devices that offload heavy processing tasks to servers. For instance, Chromebooks largely rely on remote servers for computational power, focusing more on facilitating access than processing data locally. Contrast this with thick clients like a fully equipped laptop running software and calculations independently, only relying on the server for storage or updates. Each approach has its strengths, whether it's the scalability of thin clients or the self-sufficiency of thick ones. In larger systems, we encounter multi-tiered architectures, especially the elegant three-tier model. 1. Clients manage presentation, what the user interacts with. 2. Application servers handle the business logic, processing requests and making decisions. 3. Database servers store and retrieve the actual data. This distribution ensures efficiency, reliability, and growth potential. For instance, think about popular web platforms. When millions of users access their profiles simultaneously, these tiers ensure everything runs smoothly behind the scenes. The security puzzle security is the cornerstone of any networked system. Let's zero in on firewalls, the unsung guardians of the digital world. Every time your device communicates externally, firewalls scrutinize the data packets involved and ensure they comply with established rules. Firewalls come in several flavors. 1. Packet filtering firewalls check packet headers and enforce simple rules, quick but not foolproof. 2. Stateful inspection firewalls go deeper, tracking ongoing sessions to verify incoming responses. 3. Application firewall systems operate at the software level, using proxies for various services like HTTP or FTP. This extra processing enhances security, but can slow down performance. One advanced structure gaining traction is the screened subnet firewall, where a demilitarized zone, DMZ, isolates public-facing servers from internal systems. Think of it as a buffer zone. Any intrusion targets this isolated space rather than the internal network. Shadows in the system, understanding shadow. If beyond the firewalls and user controls, there's also shadow IT, unauthorized tools, software, or systems used within organizations. While shadow IT can fuel innovation, it often bypasses critical security protocols. From unvetted apps to unauthorized cloud services, it's like adding a hidden room to your house without checking its structural integrity. Gradually, it compromises the entire foundation. To address this, organizations are adopting comprehensive strategies, such as strict access controls, robust training programs, and consolidated procurement systems to avoid rogue tools. Shadow IT may loom like an inevitable risk, but with awareness and preparation, its benefits can be harnessed while risks are contained. The human element. Finally, the journey into networking isn't just about technology, it's about people. Whether deploying secure systems, monitoring activities, or managing help desks, humans remain at the heart of innovation and protection. By combining technical knowledge with vigilance and ethical responsibility, we can ensure networks continue to be the bridges that make a connected world possible. This narrative creates a captivating educational video by expanding on each theme in digestible, story-like segments while respecting the text's depth and scope. Each section can be adapted further to integrate examples or visuals to enhance engagement. Let me know if you want further refinements. Thank you for watching, and as always, continue learning. Stay curious, and we'll see you next video.